This example involves a car loan with a down payment. Erin wants to buy a $39,000 car. She's planning on making monthly payments of $800 for 4 years, and the interest rate on the loan is 4% compounded monthly. How much will her down payment need to be to make this happen? My first reaction is, wow, $800 a month. That's a big chunk of your monthly budget. So the advantage here would be paying it off in a short period of time. Overall, she'd be paying less total in interest, because if you spread it out, you can make the payments lower. Spread it out over a longer period of time, the payments would be lower, but you'll be paying more interest because of that longer period of time. So there's an incentive to make it a shorter term loan, but that makes the payments higher. And I can see that's what's happening here. And $39,000, that's not a cheap car. So $800 a month, that's what's given. 4% interest, 4 years. But we want to figure out basically how much would she be paying off with that monthly payment, and then the difference between what she'd be paying off and the $39,000. That's what you'll have to cover initially as a down payment. So we go back to this payout annuity and loan formula. That looks like this. There's a P0, that's sort of the starting amount of the loan on which the interest is charged. There's a value D. There's a 1 minus 1 plus, it's R over K, and then a negative NK, everything divided by R over K. So in this formula, the P naught is the starting principal amount in the annuity or in the loan. The D is the regular payment. The R is the annual rate. The K is the frequency of compounding. And N is the number of years. So in this case, we don't know what that starting balance would have to be that she would cover with these $800 a month payments. How much would she pay off by doing that? She would pay off the initial amount of the loan, which is the question. The payments are $800. There's a 1 minus 1 plus that's part of this formula. It's 4% interest, and it's monthly compounding and monthly payments. So K is 12. There's a negative in the formula. It's a period of 4 years, and again, the K is 12. That's the frequency of payment and compounding. And then everything is divided by the 0.04 divided by 12. So that's a lot to type all into the calculator at once. But certainly something we want to use the calculator to help with. So because of how much it is to type all at once, you could, with a calculator like this, we could type it all at once. But maybe if you've got the TI-30 or just a basic scientific calculator, what I would recommend is that you just do what's in the brackets here first, because the one place where a rounding error could be significant, really significant, is when you compound the rounding error. So if you have this exponent that's here like a 48, and you round off at this inside amount here, you compound that rounding by raising it to a power. That would be the most likely cause for some error and to miss. I want this final answer to be to 2 decimal places. So let's just put what's in the bracket in the calculator as one step. So I'll type 1 minus, and then the quantity 1 plus 0.04, and I'll divide that by 12. And then I'll raise that to a power. And you could type negative 4 times 12, or you can just type negative 48, right? Negative 48. And that gives me just part of it. So I'll say now at this point I have P0 is 800 times this quantity 0.147629. And it's not clear how many places I really have to round. Here, I want my final answer to be 2 places, so probably 4 at this place would be sufficient to be accurate to 2 at the very last step. But I'll write some extra decimal places just for a little more confidence. And then at the bottom, I have to still do that. Now, the next step is you could type all that in on the calculator, And actually, that's actually pretty reasonable because I'm not solving for the payment. I'm just simplifying that expression. So I think that's actually what I'll do. I'll just type all of this into the calculator in one shot, just to increase the accuracy rather than typing in part of it, writing it down, which would cause me to round it off, and then type it back in. I add up. I'm adding the errors, the rounding errors. So let's avoid that. Let's keep it as accurate as possible. So say 800 times the 0.147629, and then I have to divide. I have to be careful here because I'm dividing by a fraction. So I'm going to say divide by, and I'll create parentheses, 0.04, and I'll divide that by 12. Like even if you got the decimal here, if you rounded it off too much, you could end up a little bit off when you go to two places. So let's keep that one accurate there, and then so that's $35,430, close to the price of the car. So that's paying off a balance of $35,430 and 96 cents. That's what an $800 payment would do if you did an $800 payment every month with 4% interest. That 4% interest is continuing to be compounded on whatever the remaining balance is. And if it started at $35,000, $800 would pay off that loan, right? So, but the car, of course, was a little bit more than that. So that's what we're after. How much does she have to pay initially as a down payment so that $35,430 covers the total? So you just take the $39,000 price of the car, $39,000 minus the $35,430 and 96 cents, and subtract those. So 39,000 subtract, and then I'll just say subtract that. And it looks like 3569. So after you take the price of the car and minus off that loan repayment total, the difference is what we would have had to have paid initially. So that, if you had a $39,000 car and you paid off that you made the down payment of $3569, then the rest of the loan would be $35,430, and the $800 a month payment would cover it. Okay, so that's the answer for that one. Hope that helps.